the Hackaday Prize calls on us to build something that matters. And this community answers that call, answers it with quite a lot of kind of spectacular hardware. And some of this stuff is funny, some of it's artistic, some of it has something to say, but it all matters. I mean, it all has, every Hackaday Prize entry has something that we can learn from, something to be inspired by. It all matters. But every year we find that there are some entries that are aimed at solving problems in developing countries. And this in particular is an area where there's a pretty big gap between building something that's technically awesome and having that applied in a real way so that it has impact in a developing country. And that's what I want to talk about today. So I have kind of an unusual perspective on this. So as Magenta said, I work for an organization called Development Alternatives Incorporated, or DAI. And DAI is an international development company. And what that means is we're engaged by donors like the U.S. Agency for International Development to implement projects that build capacities of people and institutions in developing countries. This is supposed to be blank, by the way, if that's freaking you out.
Oh, okay. Great. Thank you.
Yeah. In the notes, it says this slide intentionally blank, but maybe I should have put it up on the slide, but then it wouldn't be blank anymore. Where was I? Okay, so we implement development projects, and I think when a lot of people think about foreign aid, they're thinking about humanitarian aid that is meant to bring countries back up to a baseline after a major crisis like a famine or a war or a natural disaster. That's not really what we do. We work in international development, so we're actually looking to raise the baseline so that countries are more prosperous, better governed, healthier places for the people that live in them. And so I run this DAI Maker Lab where I'm applying the same kinds of tools and approaches that people are using to build the Hackaday Prize entries, to build hardware and build capacities around hardware in support of those projects. So I've worked in development for almost 25 years, and I've been running the DAI Maker Lab since 2015. So that's my kind of oddball perspective on this. I'm really an aid worker who's using sort of maker-grade skills and tools to build hardware rather than an engineer who's dabbling in aid. So it's important to keep that perspective in mind because humans are deeply rooted in our perspectives, right? We're very context-sensitive creatures, and we carry our native context with us wherever we go. So the place where you grew up, your social economic class, the language that you speak and think in, all kinds of other things form your native context. And you carry that context around with you, and it forms the lens that you look at the world through. And like any other lens, it's kind of invisible to you. You tend to forget that it's there. Our technology, our hardware, is human material culture. And like any human material culture, it also gets stacked up with context. And some of this is stuff that we bake in there on purpose. And some of it is stuff that we stick in there because we didn't even realize we were doing it. Our lens doesn't give us any other point of view to look at this. And it's very common in international development projects to have to take a piece of hardware and apply it in a developing country context. So you go to another context and you drop in that hardware, and what you very often find is that it doesn't work out very well. So you go back in 5 years and you find the thing is broken, or it's been unplugged since about 2 weeks after you left it there. People didn't like using it. People were nervous about it. Maybe it never worked. There's all kinds of reasons that these things don't work. And the reaction that people tend to have when that happens is to say, well, this country just isn't ready for that kind of technology, which is exactly backwards. That's not the problem at all. The problem is that that hardware was built for a different context. It wasn't built for this context. It was built with other assumptions in mind. And this is what's so beautiful about the moment we're living in now. This slide is intentionally left blank. We're living in a moment where we have all these new tools and approaches where we can build hardware in all kinds of contexts that we couldn't before. We don't need the same kinds of infrastructure and capital behind us in order to build hardware and build it in these different contexts. Now, when I talk about this, and particularly when I talk about this to a hardware audience, the objection that I frequently get is about scale. So yes, we have these tools. We can build things in quantities of 1 or 10 or 100 way easier than we could 15 years ago, but the process of going from 100 to 10,000 or 50,000 units is kind of about as hard as it used to be, right? And that's not wrong, right? I'm not arguing against that, but there are two responses I have to this question about scale. And one is just about the word scale. I don't think it means what you think it means. So we've kind of turned this word scale into a synonym for to embiggen. And that's not what it means in English. In English, we can scale stuff up and we can scale stuff down. Scale is about making stuff fit right to where we're trying to put it. And to be sure, the problem often, the difficulty is in scaling up, right? And that's where we put our focus because that's what's hard. But when it comes to hardware, the way that you apply hardware to a 10,000 unit problem is pretty well understood. It's not necessarily easy, but it's mass manufacturing, and we know how to do that. And that's how you cost effectively apply hardware to problems in a 10,000 unit situation. What's new is that we have tools to cost effectively apply hardware to situations that are less than 10,000 unit situations. So this is where a lot of the unmet potential lies, where there's a lot of unmet needs that can be addressed with hardware. The second objection I have to this, or the thing that I would raise, is that you don't necessarily need many units of hardware to affect a lot of people. So I'll give you two examples from my own work. So this is something called Tepmacha. It's a sonar stream gauge, and we've built similar hardware for other countries, but this particular model is built for Cambodia. And so basically we hang these usually off the side of a bridge, and it uses sonar to read the level of the water underneath that bridge. Uses cell phone networks to send that information to a cloud-based server where it can be logged and tracked. And then when the water exceeds levels that are marked here in yellow and red, it triggers, the Cambodian version triggers an alarm in an interactive voice response system. So this is an automated phone system that makes a voice phone call to, say, 10,000 people downstream within a matter of a few minutes. And in a rural Cambodian context, that voice phone call is really important because if you send an SMS alert, right, you have the kind of literacy issues that you might expect. But what you might not expect is that most phones don't render the Khmer character set correctly. So even if you can read, the chances that you're going to be able to get that text through in a way that you're going to be able to read it are low. So this is something that contextually fits the Cambodian environment. Now, the NGO that we work with that runs this interactive voice response system, they have 5 units in the field right now that serve 72,000 subscribers with data. So you can hit a lot of people with just a few units. Another thing that we're working on right now in Indonesia, we're working with some young innovators out of a makerspace in Jakarta on open source designs for water pressure telemetry units for small water utilities in Indonesia. So this is something that a utility can put up throughout its water network and get better information about what's happening in its distribution system. So with these units, they can provide more effective, more efficient, cleaner water for their subscribers. And a municipality of 1 or 2 million people can probably cover their entire municipality with 40 or 50 of these. So small-scale hardware can actually make a lot of difference for a lot of different people, for many people. And this slide is intentionally left blank. All right, so how do we do that? How do we, if we believe, and I really do believe, that small runs of hardware can actually kind of change the world, which is a cheesy thing to say, but I not only believe that that's true, but I kind of believe it's inevitable. I don't see how having the ability to do that could fail to have an impact. So how do we do that effectively? How do we make it matter for developing countries? I'll give you a number of sort of observations and suggestions from my experience doing this for a few years. So number one is to build capacity and not just hardware. So it's one thing to give somebody a piece of hardware that's going to solve a problem for them that's been designed for the context that they live in. It's another to give people who are living that context every day and are living those problems every day the ability to make their own hardware or to adapt the hardware that you've made for them. So building their capacity is actually much more important than building the thing. And you can do both at the same time. You can engage that local capacity in the design and building of your solution. And in fact, it's going to help you in a lot of ways. And you'd be surprised in many of these countries how much capacity there sometimes is that's there and willing to work with you. Open source is really important, and I don't think that's a controversial view in this room. In addition to open sourcing your own design, you should really look to your tool chains. Think about how it is that you're building and people can reproduce this. So when I lay out circuit designs, I do it in KiCad. When I'm doing firmware, I'm using GCC-based tool chains. Stuff that people can readily pick up and use no matter what their resource constraints or other things are. I think there's a lot of discomfort with the Arduino IDE for reasons that I totally get, but the Arduino IDE is really easy. It's pretty simple to use. It's open source, and people all over the world are very familiar with the Arduino IDE. It has certain advantages that you can take advantage of. Produce clear, usable documentation. I think everybody probably realizes that open source is more than just a license. If people don't have the documentation to replicate your design, then that's no good to them. But when you're thinking about developing countries, you need to be thinking about how you write your documentation. Is there a lot of idiom in it? Are there a lot of words that people are going to struggle with? Think about a wider audience than maybe the person that you're traditionally writing for. And you don't have to be making hardware for developing countries in order for this to matter. People all over the world are looking at your GitHub repos. People all over the world are looking at your projects on Hackaday.io. And I know because I talk to people all over the world about stuff they've seen on Hackaday. And also be nice, right? If you're answering questions on Stack Overflow or somewhere else, being nice goes a long way. Don't make fun of people's English if their English isn't perfect. Not just because of the person you're interacting with, but other people are going to come along and read that later, and it might discourage them from asking a question. So let the problem drive. You might be looking at a particular problem set because you have access to a tool or a technology that you think can crack that set of problems open in a way that wasn't true before. And that's fine. But always let the problem drive the solution and not the other way around. If you let the solution drive, then that's a shortcut to getting lost really quick. And don't be afraid to walk away if your solution that you had in mind, and if it's the one tool that you've got to bring to the problem, isn't working out. If you keep digging at that, you're just going to waste your time and other people's. If you're dealing with a context and a problem that you're not living every day, you need to recognize that you have an incomplete understanding of that problem space and figure out how to fill that gap. Figure out what you don't know and what you don't know that you don't know, and start to inventory that and figure out how you're going to deal with that. And I'll give you some suggestions of tools you can use to do that. Understand the tools that are currently in place to address this problem. So how are people dealing with this right now? Not necessarily technological tools. How do people address this issue now? And if you understand that, you can get insight into what has worked for people in the past and what hasn't. And you get insight into what people expect this thing to work like. So if you start to look at that, you can see how your solution might interact with users in a way that they might be familiar with. So understand the stakeholders. Stakeholders is a word that's kind of become a punchline, right? And if you guys think you're sick of the word stakeholders, international development people are way sicker than you are of the word stakeholders. But I use this word advisedly because, yeah, it's really important to identify and deeply understand the users of your thing that you're building, but you also need to understand who else is going to be impacted by this. So there are a whole lot of people who are not necessarily direct users of your solution or of the problem that you're trying to solve, but who are impacted by this, and you need to take those into account. Are you going to be putting somebody out of work or otherwise affecting their livelihood if what you do works? That's presumably not your intention, and even if you feel like it's worth it, That's going to create a whole lot of issues and resistance to what you're doing locally. Is government going to take an interest in what you're doing, either because they have a direct interest in what you're doing or because you're doing something like working with radio frequencies that are regulated? So government, don't assume just because the government looks inefficient that they're not going to find their way to you. You need to take that into account in your design. And depending on what you're doing, there are probably lots of other stakeholders that you need to take account, and you really need to inventory those. It's important for other steps down the way. So what do those stakeholders want? What do they not want? You need to understand that. And how can those stakeholders help you, and how can they hurt you? And in some cases, they can literally hurt you or hurt people that you're working with. If you're messing with somebody's livelihood, somebody might well hurt you. So you need to take that into account. So design for sustainability. Sustainability is the bugaboo of all development work. It's really easy to do a project or put down a piece of hardware or lay down a road. Making sure that that thing is still there and working for people years down the road, that's really the hard part. And so that's something that you need to think about at the design stage, and it really needs to be built into your design. So you need to get buy-in from those stakeholders that you identified, or you need to figure out how you're going to deal with the ones you can't get buy-in from. So who's got enough of a stake in the success of this thing that they're going to be willing to pay the costs of keeping it going? And that's not just the economic cost, not just money, but the time and the opportunity cost based on that. So do you have a set of stakeholders that have enough skin in the game that they're going to be willing to do that, and do they have the resources to, in fact, be able to do that? Who maybe has a stake in making your thing fail? And so there's the people that you might have already thought of, the people who are obvious, and then people who might not be obvious. And I'll tell you a story. So before we did sonar stream gauges in Cambodia, we piloted them in Honduras. And we took them around and put them up in a variety of different places in Honduras. And generally, when we go to a little town, we'd put them up on a bridge. The whole town would come out to have a look at what was going on. It was like a little local excitement. And my Spanish is pretty bad, but my colleague up there in the blue-green shirt told me later that these kids behind him were discussing who was going to be able to take out the solar panel on this unit first with a slingshot, right? And they were really excited about the target practice. There's nothing in my stakeholder analysis that took that into account, but it's something that you need to think about. There are these little things that come up. Who might misunderstand your intervention? So also in Honduras, we put up one of these units in a pretty bad neighborhood in Tegucigalpa. And we were approached, as we were doing the installation, by somebody who came up to us and started asking questions about what this thing did and whether it took video. And we took great care in explaining to this person exactly how this thing worked and exactly what it was for, and let them poke around it and examine it, because if that person misunderstood what it did, that could be one of those cases where somebody might hurt you, or at least, take the thing down with a baseball bat the next day. Recruit other allies. So they may be people that are not direct stakeholders of what you're trying to do that you can bring into the fold and recruit. So again, with sonar stream gauges, one of the things that you notice when you do these is that bridges are a great funnel for foot traffic from both sides of the river, so they tend to attract like a little roadside restaurant by the side of the bridge. And so kind of everywhere we go, there's some kind of a cafe or something next to the bridge, and we'll generally hang out there while we do our installation. We'll order a bunch of food, we'll order some drinks, we'll tip nicely, we'll be very nice, and we'll trade phone numbers with the owner and give them a little bit of a bit of money at the end. And that way we have somebody who's there who can shoo away kids with slingshots, right? And who you can call if the thing stops working and say, is it still there? Is there something obviously wrong with it? Or if they see something going on with it, they can call you and say, hey, there's something happening here, or people are talking about this in such a way, and then you can do that. So that's not necessarily a direct stakeholder, but you can kind of make them a stakeholder through the back door. So this is probably obvious, but design with the long-term enabling environment in mind. You need to be thinking about where spare parts are going to come from, who's going to be repairing this thing, because stuff breaks. That's just what stuff does. And watch out for unintended consequences. There's always the consequences that you're planning for, that you're designed for, and then other stuff happens, and you need to kind of try to anticipate that as well as you can, so you can take account of that in your design. So the design with and not just for your users, and this is kind of where all of this comes together. So you need to engage your stakeholders in the design process. Don't design for them and plop it in front of them. You need to engage them in the design. And the best way to do that is through a human-centered design framework. And there's a bunch of these frameworks that are out there. They're all a little bit different. None of them are rocket science, although some of them seem to try to convince you that they are. They're all a little bit different, but they mostly kind of look something like this. So you've got problem definition and looking at what the desired outcome would look like. You've got a design loop, and then you've got deployment. So the first thing you do is you sit down with your stakeholders that you've identified and work out what is that problem and what would a solution to that problem look like. So talk that through, look at that, document all of what that looks like. Then you, again, with your stakeholders, ideate on what that solution might be, how that solution might look, and you prototype that. And in your early iterations of this design loop, those prototypes are really just going to be like cardboard or Play-Doh. It's just a touchstone so that you have a place to discuss with your stakeholders, what is this going to look like and how is this going to be, and is it more like this or more like that? And then you can collect information from them about how that lands with them and iterate. One thing I've discovered with Internet of Things devices in particular, once you get past the cardboard stage, it's a good idea to get an enclosure that you think is a realistic size and the sorts of connectors you think you might need. So just an empty box with wires coming out of it, and go and install those in a bunch of places. And that process of installation will often tell you a bunch of things that you would not have thought of just sitting around a table. And then ultimately in the later design phases of the design loop, you're going to get to actual working field prototypes, stuff that does electronic-y things. So after your prototype phase of each design loop, you're going to test and collect feedback, and that's going to feed into your ideation for the next set of the loop. And this loop is going to go around and around and around a bunch of times until finally you're going to get to that test and collect feedback, and everybody's going to go, yep, that's great. It looks good. That's what we want, and you start to deploy. There's an organization called adeo.org that puts out a field guide to human-centered design. It's at designkit.org. I'm not affiliated with Adeo in any way. I don't even use this kit, but it's pretty slick. It's reasonably well laid out. It's easy to understand. It has the advantage of being free. So it's out there. There's lots of other ones out there, but this one's pretty accessible. It's free, and if you're talking to people about human-centered design and you mention adeo.org, they all know who that is. All right, so one thing that you might be thinking as I'm saying this, particularly if you're somebody who's like looking at wanting to do something in a developing country context, is that this doesn't sound realistic for you, right? I'm over here, I'm not over there, I can't get all that local involvement. And even if you can, and the truth is that I would never, I wouldn't design, prototype, and then try to deploy something in a context that I had not seen personally and had a chance to poke around. I just don't think it works very well. But I can't, and I'm sure you can't, afford to get on a plane and go move to Burundi for a year while you go through all these design loops. So having local partners is really important, because even if you did live in Burundi for a year, you're still not going to have the connections that you need. You're not going to speak the local language. You're not going to have that kind of local feel. And so finding local partners is really important. So non-governmental organizations are one great potential partner. Look around for NGOs that are doing work in the country that you're interested in and the region that you're interested in that's similar to what you're doing, and see if you can form a partnership there. The local maker community, and again, a lot of these countries have a makerspace, a hackerspace, or a fab lab. You might be surprised at the countries that have these. And those are good places to meet people who are interested in doing stuff with hardware and often very excited about doing stuff with hardware that's going to help their country out and learn something in the process. When I go to a country and I find that there is no makerspace, hackerspace, or Fab Lab, one of the things that I will do is I will look around to see if there's a component vendor that sells things like Arduinos and other likely candidate stuff. And I'll go and sit with that person and ask them, like, who's your customer base? Who are you selling this stuff to? That's a little bit of DAI that you can inject into the system to figure out where the maker community is. Universities can be an option. Most countries have a university or two with an engineering department, and these can be good options, but you need to recognize that universities operate on their own calendars at their own cadence. That's not necessarily compatible with anything that you're trying to do. And then another option is just, well, it's me. If you're interested in doing stuff for developing countries and you want to apply your skills in that way, I do have partnerships with a lot of universities and with some independent researchers. If that's something that you're interested in, go ahead and introduce yourself to me, and we can put you on that list. I don't have any budget for staff at the moment, but that could change someday, and so if that's something that's really interesting to you, make sure I know who you are. I think that probably is all of my time. If you have questions, I'm happy to sit out in the workshop area as long as you like, and you can sort of aim and fire those at me. And thanks very much. Appreciate it.